Good day and welcome to today's class. Today's class is a continuation of our previous classes on perfect square. At the last class, we looked at making an imperfect square a perfect square. At the previous class, we looked at making quadratic expressions perfect squares, where we said to make non-perfect squares quadratic expressions to be perfect squares, first make the coefficient of the first term of the given quadratic expression a perfect square. Then square half of the coefficient of the second or third term in order to obtain the third term. And we said this is because the middle or second term of a perfect square is always plus or minus twice the square root of the product of the other two terms, that is the first and the second term. And at that last class, I gave you some examples and I left the class with an exercise or an assignment where I asked you to find the constant that must be added to make each of the following quadratic expression a perfect square. And if that is done, then you factorize. Before we continue, kindly subscribe to this channel if you are yet to do that, while you are to use the comment section to interact with us, and you are advised to share this video, the link of this video, to your friends and family so that they can also benefit from this class. In today's class, we shall be solving the assignment I gave you at the previous class. Question 1 says a squared plus 3a. That we should find the solution. A squared plus 3a. Now what we have to do is to first of all look for that constant term that when added to this expression makes it a perfect square. Now this is a two-term expression. We need to make it a three-term expression. And what did we say is that third term that when added to this expression, it makes it a perfect square. I gave you two methods which you can use, but I will be using those two methods interchangeably so that you can perfect it. So in question 1, I'm going to use method 1, and in every even numbers, then I'll be making use of question 2, or as the spirit leads. So for question 1, that what must be added to this expression to make it a perfect square? We say let that constant term be k. And the method says you should first of all make sure that the first term is a perfect square, of which a squared is the perfect square. You find the square of half the coefficient of the second term, which is this. So the coefficient of the second term, which is 3a, is plus 3. So I'm going to look for half of 3 all squared. So half of 3 all squared is going to be our k. Okay, so this is equal to 3 over 2, and k is equal to 3 over 2 squared, and 3 over 2 squared is equal to 9 over 4. So 9 over 4 is that term which when added to a squared plus 3a makes it a perfect square. And the question says we should therefore factorize. So we have a squared plus 3a plus 9 over 4 to factorize. So how do we factorize this? This can be written as a squared plus 2 into 3 over 2a plus 3 over 2 squared. How did I get this? Remember, at the last class, or in one of our classes, which is the first class, we said if a quadratic expression can be expressed in the form x squared plus 2xy plus y squared, it is said to be a perfect square. And this perfect square can be factorized into x plus y all squared. So all I did was to write this expression in this form. And once that is done, you can thereafter factorize it in this form, where x is said to be the first term and y is said to be the middle term. So when you compare, you agree with me that this can be written as a plus 3 over 2 all squared. So when you factorize, this is what you will get.